Hello, viewers. In today's class, we are going to discuss an important problem related to three-dimensional geometry, right? So here in this session, we are going to discuss this problem related to the shortest distance between two non-coplanar lines, right? So non-coplanar lines are also known as skew lines. So here we have to solve this problem in which we have to find the shortest distance between these two lines, right? So the Cartesian equation of the two lines are given as x minus 3 over 3 equal to y minus 8 over minus 1 is equal to z minus 3 over 1, and the second line is x plus 3 over minus 3, y plus 7 over 2 is equal to z minus 6 over 4, right? So here the two lines are given in the Cartesian form, and we have to find the shortest distance between these two lines, and then we have to also find the equation of shortest distance line, right? And the points where the shortest distance line meets the given lines, right? So here let us first briefly discuss the concept of shortest distance between two lines. So viewers, let us consider two planes, right? Suppose this is the first plane and this is the second plane. And if we have two lines lying on these two planes, suppose this is the plane P1, this is the plane P2, right? And two lines, say L1, this is the line L1, this is the line L2. Now see, these two lines lie in different planes. So these two lines are said to be non-coplanar lines or skew lines, right? Now the shortest distance between these two lines L1 and L2 is given by a line which is perpendicular to both the lines, right? Suppose this is the point, say A, this is the point, say B, then this AB, this line segment AB is known as the shortest distance between the two lines L1 and L2. And always remember, the lines L1 and L2 lie in different planes, and they are non-coplanar, and AB is perpendicular to both the lines L1 and L2, right? So A is the point of intersection of the line L1 and this line AB, and B is the point of intersection of line L2 and this line AB. And this line AB is known as the line of shortest distance, right? So in this problem, we have to find the shortest distance, that is AB, and then we have to find the equation of this line of shortest distance and the coordinates of the point A and B. So viewers, we have already discussed a lot of problems related to shortest distance in our earlier videos, but here in this lecture we are not going to use any standard formula for finding out the shortest distance, right? So here in this session we are going to use the simple concept from three-dimensional geometry to find out the shortest distance, then equation of shortest distance, and the points where the shortest distance line it meets the given lines. So here we are going to use the concept of a general point lying on a line, right? So general point lying on a line. So what we will do here, let us denote this line as L1, this line as L2. Now let us introduce two scalars, lambda and mu, to get the coordinates of the general point on line L1 and line L2, right? So here lambda and mu are some scalars, right? So let us find out the coordinates of the general point lying on this line L1. So we have the point x minus 3 over lambda. We'll frame three equations here. Then we have y minus 8 over minus 1 is equal to lambda. Z minus 3 over 1 is equal to lambda, right? So from here, x is equal to 3 lambda plus 3. From here, y is equal to minus lambda plus 8, and z is equal to lambda plus 3, right? So the coordinates of this point A may be taken as 3 lambda plus 3, then we have minus lambda plus 8, and then we have lambda plus 3, right? Now similarly, let us calculate the coordinates of the general point lying on this line L2. So here we have x plus 3 over minus 3 is equal to mu. Then we have y plus 7 over 2 is equal to mu. Z minus 6 over 4 is equal to mu, right? So we can now write x is equal to minus 3 mu minus 3. Here we have y is equal to 2 mu minus 7. Then we have z is equal to 4 mu plus 6, right? So now the coordinates of the general point lying on this line L2, that is the coordinates of the point B, may be taken as minus 3 mu minus 3. Then we have 2 mu minus 7, and then we have 4 mu plus 6, right? So the method we are using, we have to first find the coordinates of the general point lying on the lines L1 and L2. So now the next step is to get the direction ratios of this line AB, right? So we have to find the direction ratios of the line of shortest distance, that is AB, right? So we know that if we have 2 points, say x1, y1, z1, and x2, y2, z2 as A and B, then the direction ratios of this vector or the line AB may be obtained by subtracting the coordinates, right? So x2 minus x1, then we have y2 minus y1, z2 minus z1. So these are the DRs or the direction ratios of the vector AB. So here x1, y1, z1 may be taken as 3 lambda plus 3 minus lambda plus 8 and lambda plus 3, and x2, y2, z2 can be taken as minus 3 mu minus 3, 2 mu minus 7, and 4 mu plus 6, right? So to get the direction ratios of AB, we have to subtract the coordinates, right? So the direction ratios may be obtained like this. So we have minus 3 mu minus 3, minus 3 lambda minus 3. Then we have 2 mu minus 7 plus lambda. Here this negative sign becomes positive. Then we have minus 8, then 4 mu plus 6 minus lambda minus 3, right? So let us simplify. So we have minus 3 mu minus 3 lambda. Here we have minus 6, then 2 mu plus lambda minus 15, and then we have 4 mu minus lambda, and 6 minus 3 is 3, right? So these are the direction ratios of the shortest distance line. So now viewers, here we can see that the direction ratios of the line L1 are given by 3, minus 1 and 1, right? So direction ratios of L1, these are the direction ratios of AB. and direction ratios of L1 are given by the numbers 3, -1 and 1, right? And direction ratios of the line L2 are given by -3, 2 and 4, right? So now the line of shortest distance is perpendicular to both L1 and L2, right? So when AB is perpendicular to L1, then we can have, see, 3 times, here the direction ratios of L1 are 3, -1 and 1, and the direction ratios of AB are given by these three numbers, right? So when two vectors are perpendicular, then the product of the direction ratios, the corresponding direction ratios, and their sum is equal to 0. Or in other words, we can say that A dot B is equal to 0, right? So we have 3 times, here we have -3 mu minus 3 lambda minus 6 plus, here we have -1 times 2 mu plus lambda minus 15, and then we have here 1 times 4 mu minus lambda plus 3 is equal to 0, right? Because if we have the direction ratios a1 b1 c1 of one line and a2 b2 c2 of other line, and if the two lines are perpendicular, then we have a1 a2 plus b1 b2 plus c1 c2 is equal to 0, right? So we are using this concept here. So now, simplifying this equation, we have -9 mu, then we have -9 lambda, then we have -18, and then we have -2 mu plus lambda minus, here we have minus lambda, then we have plus 15, and then we have here 4 mu minus lambda plus 3 is equal to 0, right? Okay, so now see here -9 mu, here we have -2 mu, that is -11 plus 4, that is -7 mu, right? And here -9 -1 -1, that is -11 lambda, and here we have -18 plus 15 -3, and 3 and -3 get cancelled, so we have simply 0, right? So let us call it equation number 1. So let us write this equation over here. -7 mu minus 11 lambda is equal to 0. Now, since this line of shortest distance AB is also perpendicular to L2, so let us now apply this result to these two direction ratios. So now AB is perpendicular to L2. So we have now -3 times, -3 mu minus 3 lambda minus 6, then plus 2 times 2 mu plus lambda minus 15, and then we have 4 times, here 4 mu minus lambda plus 3 is equal to 0. So this is minus minus plus, so we have 9 mu, then 9 lambda, then 18, then here we have 4 mu, here we have 2 lambda, then we have 30, 2 15s are 30, then here we have 16 mu, then we have 4 lambda, then we have here 12, right? So 9 mu, 4 mu, and here we have 16 mu. So 9 plus 4, 13, 13 plus 16 is 29, right? Here we have 9, this is 2, 9 plus 2, 11, 11 minus 4 is 7 lambda, right? Here we have 18, here we have 12, so 18 plus 12 is 30, so 30 and 30 get cancelled, so this is equal to 0, right? So we have another equation that is 29 mu plus 7 lambda is equal to 0, right? So now we have two linear equations in mu and lambda. So let us solve these two equations for lambda and mu. So viewers, now if we look at these two equations, we can see that minus 7 mu minus 11 lambda is equal to 0, 29 mu plus 7 lambda is equal to 0. So if we solve these two equations, we can easily conclude that the solution lambda is equal to 0 and mu is equal to 0, right? So we have the solution lambda is equal to 0 and mu is equal to 0. So now using the values of lambda and mu, we can find out the coordinates of point A and B, right? So taking lambda is equal to 0 here, we have the coordinates of A as 3 times 0 is 0. So we have 0 plus 3, then we have minus 0 plus 8, and then we have 0 plus 3, right? So the coordinates of this point A are 3, 8, and 3, right? So here the coordinates of this point A are 3, 8, and 3. Let us find out the coordinates of the point B. So taking mu is equal to 0 in this coordinate, we have the coordinates of B as here we have 0 minus 3, then we have 0 minus 7, then we have 0 plus 6, right? So here we take the value of mu as 0. So this is minus 3, minus 7, and 6, right? So the coordinates of this point B are minus 3, then we have minus 7, and then we have 6, right? So now the direction ratios of this line of shortest distance, that is AB, can be obtained by taking mu is equal to 0 and lambda is equal to 0, right? So we have direction ratios of AB as 0, then here we have 0, 0, then here we have minus 6 only, here we have 0, then we have minus 15, and here we have 0, so we have 3, right? So the direction ratios of this line of shortest distance is given by minus 6, then we have minus 15, and then we have here 3. So now the shortest distance between these two lines L1 and L2 can be calculated by using the distance formula in three-dimensional geometry, that is the square root of x2 minus x1 whole square, y2 minus y1 whole square, and then z2 minus z1 whole square, right? So we have shortest distance. So x1 y1 z1, this is x2 y2 z2, so we have minus 3 and minus 3 whole square, then we have minus 7 minus 8 whole square, then we have 6 minus 3 whole square, right? So this is minus 6 whole square 36, this is minus 15 square 225, and this is 3 square 9, right? So now we have a square root of 270, and that is equal to 3 times square root of 30, right? So the shortest distance is equal to 3 times square root of 30, right? So now let us find out the equation of the line of shortest distance. So the equation of shortest distance is given by the standard form, that is x minus x1 over x2 minus x1, then we have y minus y1 over y2 minus y1, then z minus z1 over z2 minus z1, right? So x2 minus x1, y2 minus y1, and z2 minus z1 are the direction ratios of this line of shortest distance, right? So we can take x1 y1 z1, x2 y2 z2. So the equation of shortest distance is given by x minus 3, this is x1 y1 z1, and then we have minus 3, then we have y minus 8, then we have minus 7 minus 8, and then we have z minus 3, then we have 6 minus 3, right? So this is x minus 3 over minus 6, y minus 8 over minus 15, and z minus 3 over 3, right? So this is the equation of the line of shortest distance. So viewers, here we also see that these three numbers, that is the direction ratios minus 6, minus 15 and 3, have a common factor 3, right? So let us divide these three numbers by minus 3, right? So we have here 2, then here we have simply 5, and here we have minus 1, right? So the equation of the shortest distance may also be written as x minus 3 over 2, y minus 8 over 5, and then z minus 3 over minus 1. So now the third part is the points where the shortest distance line meets the given lines, right? So we have already calculated the coordinates of the point A and B. So the line of shortest distance, it meets the line L1 at point A, whose coordinates are given by this, that is 3 comma 8 comma 3, and the line of shortest distance, it meets the line L2 at this point B, whose coordinates are minus 3, minus 7 and 6, right? So this is all about this problem. So this is how by making use of the concept of general point lying on a line, we can solve this problem related to shortest distance.